Good morning, children. Welcome to your maths class. Children, in the last class you had learned 7 definitions which was given by Euclid and yes, let us recall it again. And then we will going to study Euclid's assumed properties which were not to be proved. Children, can you list Euclid's 7 definitions that you had learned in the last class? Yes, here it is. And the first and the third definition he stated a point, and in his second, fourth and in his sixth definition he stated a line, and in fifth and seventh definitions he stated a surface. Yes, he defined a point as which has no part. So we can't show a point like this. Yes, children. Here is a dot, but this is not a point. It is just a representation of an abstract word point. Because as you know that the point has no part, isn't it? Then how can we write an object without any part? So this is not a point. If we observe an object which is in the form of a straight line, its ends look like this dot. So we take that dot as a point. It is for just representation. Okay, I hope you understood what a point is. In his second, fourth, and sixth definitions, Euclid defines a line as a line is a breadthless length which lies evenly with the points on itself, and the edges of a surfaces are lines like this. Yes, children. Again, we can't write or draw a line because as you know that line doesn't have thickness. Then how can we write an object which doesn't have thickness? Again, this is also a representation of a line which is abstract. And in his fifth and seventh definitions, he defines a surface, like a surface has a length and breadth only, and a plane surface is a surface which lies evenly with the straight lines on itself. So these all are the 7 important definitions of Euclid that you had learned in the last class. Children, you might have wondered, do we need to prove everything in that we state in mathematics? And if not, why? Why not? The fact is that every area in mathematics is based on some statements which are assumed to be proved and are not proved, which are assumed to be true and are not proved. ಹೌದು ಮಕ್ಕಳೇ, ಅಂತಹ ಸ್ಟೇಟ್ಮೆಂಟ್ಸ್ ಅಥವಾ ಹೇಳಿಕೆಗಳನ್ನು ನಾವು ಸತ್ಯ ಅಂತ ಒಪ್ಕೊಳ್ಬೇಕು, ಆದರೆ ಅದು ಸತ್ಯ ಅಂತ ಪ್ರೂವ್ ಮಾಡಲಿಕ್ಕೆ ಸಾಧ್ಯ ಇಲ್ಲ, ಆಗೋದೇ ಇಲ್ಲ ಅದನ್ನ ಸತ್ಯ ಅಂತ ಪ್ರೂವ್ ಮಾಡಲಿಕ್ಕೆ. ಅಂತಹ ಹಲವಾರು ಸ್ಟೇಟ್ಮೆಂಟ್ಸ್ ಮೇಲೆ ಮ್ಯಾಥಮೆಟಿಕ್ಸ್ ಡಿಪೆಂಡ್ ಆಗಿದೆ. ಇಂತಹ ಸ್ಟೇಟ್ಮೆಂಟ್ಸ್ ಗಳನ್ನೇ ನಾವು ಸೆಲ್ಫ್ ಎವಿಡೆಂಟ್ ಟ್ರೂತ್ಸ್ ಅಂತ ಕರಿತೇವೆ. ಸೊ ಯೂಕ್ಲಿಡ್ ಅಸ್ಯೂಮ್ಡ್ ಸರ್ಟೆನ್ ಪ್ರಾಪರ್ಟೀಸ್ ಅಂದ್ರೆ ಒಪ್ಪಿದಂತಹ ಹೇಳಿಕೆಗಳು. ಯೂಕ್ಲಿಡ್ ಅಸ್ಯೂಮ್ಡ್ ಸರ್ಟೆನ್ ಪ್ರಾಪರ್ಟೀಸ್ which were not to be proved, and he divided into 2 types, that is axioms and postulates. Yes, now we are going to define what is an axiom and postulate. So now we are going to define this as axioms and postulates are self-evident true statements. Yes, these are self-evident true statements. In these definitions, it seems the words that is self-evident truth and the word statements need further explanation, isn't it? Let me recall what a statement means. Yes, children, you remember? In the last video I told what a statement means. Yes, okay. Again, I wish to clarify that. Children, if I say x plus 10 is greater than 15, okay, x plus 10 is greater than 15, is this a statement? No, this is not a statement, isn't it? Why? Why this is not a statement? Yes, because this sentence is not always true. How? If I put x is equal to 2, if I put the value of x as 2, then the sentence becomes 2 plus 10, that is 12. 12 is not greater than 15, no? Or otherwise, if I take the value of x 3 as value of x, or 4 or 5, the other numbers which are less than 6, what is the value of x plus 10 becomes? Yes, it becomes less than 15. No? So, this sentence is not always true, isn't it? Yes. Okay. When it is always true? When when x plus 10 is greater than 15 if x is greater than 6. Here, I put one condition for this sentence. When x plus 10 is greater than 15, if x is greater than 6. Yes, if you put the value of x as 6 here, the value becomes 16. No? So, 16 is always greater than 15, or other numbers which are greater than 6. If you put x as 7, it becomes 17. No? 17 is always greater than 15. Now the sentence becomes true, isn't it? Always true. So this sentence is now, it becomes a statement because this is always true. So a statement should be always true, isn't it, children? So I hope you understood what a statement means. A statement should be always true. Okay. There is another word. Another word should be explained in the definition of axioms and postulate. What is that? Yes, the self-evident truth. Yes. Let me explain this. Children, you agree with the statement like sun rises in the east and sets in the west? Yes, this is a statement. You agree with this. Do you agree with this? Yes, of course, you agree. Why? Because every day you are watching this incident as every morning sun rises in the east and it sets in the west, isn't it? So you simply assume this statement is true without other thoughts, isn't it, children? But you can't prove this, isn't it? But okay, let me take other example. As you know that half plus half is equal to 1. Do you agree with this statement? Yes, you agree with this. This is true. But you can't prove this, isn't it? We are not able to prove this logically, but by practical demonstration we can prove. Let me take another example. If you cut an apple, a whole half apple, and compare its parts with the whole apple, these parts are always smaller than this whole apple, isn't it? So these parts are always smaller than, the whole apple is always bigger than its parts, isn't it? You assume this. Simply you assume this, but you can't prove this statement. ಅಲ್ವಾ? ಇದನ್ನು ನೀವು ಪ್ರೂವ್ ಮಾಡಲಿಕ್ಕೆ ಸಾಧ್ಯ ಇಲ್ಲ. ಹೇಗೆ? ಒಂದು ಪೂರ್ತಿ ಆಪಲಿನ ಎರಡು ಭಾಗಗಳು ಒಂದು ಪೂರ್ತಿ ಆಪಲ್ಗಿಂತ ಚಿಕ್ಕದು ಅಂತ ಹೇಳಿ ಪ್ರೂವ್ ಮಾಡ್ತೀರಿ. ಹೇಗೆ ಪ್ರೂವ್ ಮಾಡ್ತೀರಿ? ಮಾಡ್ಲಿಕ್ಕೆ ಆಗುದಿಲ್ಲ. ಬಟ್ ನೀವು ಎರಡು ಆಪಲ್ ಪಾರ್ಟ್ಸ್ ಅನ್ನ ತಕೊಂಡು ನೋಡಿ, ಇದು ಇದ್ರಕ್ಕಿಂತ ಸಣ್ಣದು ಅಂತ ಹೇಳಿ ತೋರಿಸಬಹುದು ವಿನಃ. ಅದನ್ನ ನಾವು ಪ್ರಾಕ್ಟಿಕಲ್ ಡೆಮಾನ್ಸ್ಟ್ರೇಷನ್ ಅಂತ ಕರಿತೇವೆ. ಬಟ್ ಲಾಜಿಕಲ್ ಆಗಿ ನೀವು ಇದನ್ನ ಪ್ರೂವ್ ಮಾಡ್ಲಿಕ್ಕೆ ಸಾಧ್ಯ ಇಲ್ಲ. ಸಿಂಪ್ಲಿ ಯು ಅಕ್ಸೆಪ್ಟ್ ದಿಸ್, ಅಸ್ಯೂಮ್ ಯಸ್ ದಿಸ್ ಇಸ್ ಟ್ರೂ. ಹೌ ವಿಲ್ ಯು? ಹೇಗೆ ನೀವು ಅದನ್ನ ಅಕ್ಸೆಪ್ಟ್ ಮಾಡಿದ್ದೀರಿ ಇದು ಸತ್ಯ ಅಂತ? ಎಸ್, ಹೇಗೆ? You are going to assume these sentences because your intuition says that this is true and you can accept this. ಅಲ್ವಾ? ನಿಮ್ಮ ಅಂತಃಪ್ರಜ್ಞೆ ನಿಮ್ಗೆ ಹೇಳ್ತದೆ ಇದನ್ನ ಒಪ್ಪಬಹುದು, ಹೌದು ಇದು ಸತ್ಯ ಅಂತ. ಇಂತಹ ಸ್ಟೇಟ್ಮೆಂಟ್ಸ್ ಒಪ್ಪಿದ್ದೇವೆ. ಇಂತಹ ಸ್ಟೇಟ್ಮೆಂಟ್ಸ್ ಅನ್ನೇ ನಾವು ಸೆಲ್ಫ್ ಎವಿಡೆಂಟ್ ಟ್ರೂತ್ಸ್ ಅಂತ ಕರಿತೇವೆ. ಹಾಗಾದ್ರೆ ಆಕ್ಸಿಯಮ್ಸ್ ಮತ್ತೆ ಪಾಸ್ಟುಲೇಟ್ಸ್ ಅನ್ನ ನಾವು ಹೀಗೆ ಸಮರೈಸ್ ಮಾಡುವ. Axioms and postulates are self-evident true statements and are not proved. These are self-evident true statements and are not proved. Okay. Is there any difference between these axioms and postulates? ಅಲ್ವಾ, ಆಕ್ಸಿಯಮ್ಸ್ ಮತ್ತೆ ಪಾಸ್ಟುಲೇಟ್ಸ್ ನಡುವೆ ಡಿಫ್ರೆನ್ಸ್ ಇಲ್ಲದಿದ್ರೆ ನಾವು ಒಂದೇ ವರ್ಡ್ ಇದ್ರಲ್ಲಿ ಹೇಳ್ಬೋದಿತ್ತಲ್ಲ, ಆಕ್ಸಿಯಮ್ಸ್ ಅಂತ ಹೇಳ್ಬೋದಿತ್ತು ಎರಡನ್ನು, ಅಥವಾ ಪಾಸ್ಟುಲೇಟ್ಸ್ ಅಂತ ಹೇಳ್ಬೋದಿತ್ತು. But we are taking two different words here, axioms and postulates. So there is only one difference is there for axioms and postulates. Let me look at this. Okay, axioms, these are the assumptions used throughout mathematics. But postulates, these are the assumptions that were specific to geometry. Yes, both axioms and postulates are assumptions, but these axioms, we can use these axioms throughout other branches of mathematics also. But these postulates are specific to geometry only. But in these days, nowadays, we are taking both axioms and postulate as one and the same. Yes, children, I think this much explanation is enough. I hope you understood what is an axiom and postulate means. And in the next class, you are going to know about 7 axioms and 5 postulates of Euclid. ಸತ್ಯ ಏನು ಅಂತ ಹೇಳಿದ್ರೆ, ಗಣಿತದ ಪ್ರತಿಯೊಂದು ಕ್ಷೇತ್ರ ಕೂಡ ಸಾಧಿಸದೇ ಒಪ್ಪಿಕೊಳ್ಳುವಂತಹ ಕೆಲವೊಂದು ಇಂತಹ ಸತ್ಯ ಸಂಗತಿಗಳನ್ನ, ಅಂದ್ರೆ ಆಕ್ಸಿಯಮ್ಸ್ ಮತ್ತೆ ಪಾಸ್ಟುಲೇಟ್ಸ್ ಅನ್ನೇ ನಂಬಿಕೊಂಡಿದ್ದೆ. ಹಲವಾರು ಥಿಯರಮ್ಸ್ ಅನ್ನ ಈ ಆಕ್ಸಿಯಮ್ಸ್ ಮತ್ತೆ ಪಾಸ್ಟುಲೇಟ್ಸ್ ಅನ್ನ ಉಪಯೋಗಿಸಿ ಪ್ರೂವ್ ಮಾಡ್ಲಿಕ್ಕೆ ಸಾಧ್ಯ ಆಗಿದೆ. ಹಾಗಾದ್ರೆ ಅಂತಹ ಆಕ್ಸಿಯಮ್ಸ್ ಮತ್ತೆ ಪಾಸ್ಟುಲೇಟ್ಸ್ ಗಣಿತದಲ್ಲಿ ಯಾವ್ದ್ಯಾವ್ದು ಅಂತ ಹೇಳಿ ನೋಡ್ಲಿಕ್ಕೆ ಕುತೂಹಲ ಇರ್ಬೇಕಲ್ಲ ನಿಮ್ಗೆ? ಎಸ್, ಅದನ್ನ ನಾವು ನೆಕ್ಸ್ಟ್ ಕ್ಲಾಸ್ ಅಲ್ಲಿ ನೋಡುವ. Thank you, children.